Hi guys, welcome to HSC Chemistry and Chemical Monitoring and Management video series number 15 on oxygen and ozone. In this particular video, we're going to focus on the two allotropes of oxygen. Now you may recall from our preliminary course that allotropes are forms of the same element. So that is, if we compare the two elements in the same physical state, so gases is the form in which we tend to compare oxygen and ozone, they will have different properties, even though they are the same element. So this difference in properties is one of the things that we're going to focus on in this video to help us to identify some of the important differences between oxygen, O2, and ozone, O3. Most of the differences that we see in the properties between oxygen and ozone are a result of the differences in their chemical structure. Now we know that when oxygen reacts, we have to break the double bond between the two oxygen atoms. So a double covalent bond exists between two oxygen atoms, and we have to break that bond if we're going to have the oxygen be available to combine. This requires a reasonable amount of energy. Now we know that double bonds are reactive and unstable. And we've certainly looked at these in our alkenes, and so they will react and they will do so reasonably readily. But there's still an amount of energy that's required in order to break those bonds. The difference is when we look at the ozone molecule, we've sort of talked about that ozone kind of has a structure more like this rather than like this. But either way, what we find is one of those oxygen atoms is more readily split, and this leaves behind a single oxygen atom, and we'll look at actually what happens with this at a later stage. But the energy required to do that is much less than needed to break the double bond for the oxygen. Ozone is a bit of a problem in the lower atmosphere. In the upper atmosphere, so in the stratosphere, for example, that's where the ozone layer is. And that is really good, okay? That is where we want the ozone. We do not want it at ground level because it's dangerous to humans. The problem is that free oxygen atom that can be lost can then attach itself to different carbon molecules that are the key components of all living things. And what that can do is set off some series of reactions that can not only break down important compounds, but actually interfere with the functioning of the organism. And so this is a bit of a problem. What we need to do is we need to make a bit of a comparison of the properties of oxygen and ozone. Now, this could be something that you could be asked to do, and if you are, then it's important not to worry too much about the absolute numbers, but more to look at the comparisons between them. So oxygen is a colorless gas, and ozone is also a colorless gas, but it can condense to form a blue liquid, which makes it slightly different to oxygen. Oxygen can condense as well, but it forms a more paler blue liquid when it condenses. The oxygen has no odor, it's odorless, but ozone does have a distinctive odor. And so that is one of the important differences between them. And of course, oxygen is essential. So this is something that is essential for life. And down at the lower atmospheric level, ozone is actually poisonous, as I mentioned on the last slide. It's a major problem. The boiling points, well, it's about -183 for oxygen and about 111. So again, this is very low. Let's call it very low, and we'll call this low. So it's higher boiling point for ozone. The density of oxygen is about the same as air, whereas ozone is about 1.5 times air, so it's more dense. The solubility is slightly soluble for the oxygen and more soluble for ozone. Stability, well, this is what we've kind of looked at a little bit in one of the previous slides as well. And stability is reasonably stable for oxygen and readily decomposed for ozone. And it's more reactive, so therefore more reactive. And that's one of the things that we want to look at in this next one is in terms of reactive. It's strong oxidizing agent, which is the ozone, and it's moderate oxidizing agent. We know both of these are very good, but the ozone is more reactive, and it's just important to know that in terms of comparison. Oxygen is useful for life, obviously part of respiration. It's also used medically. It's used in steel making. It's also used in areas such as oxy welding. It's even used in liquid form in space shuttles. And ozone, on the other hand, can be used as a refrigerant it's used as a stabilizer for foods in the food industry, and also it's used in water purification. Now, I haven't quite hit the chemistry 300 here. I've gone a little bit over, but hopefully that gives you a bit of an overview of the differences between oxygen and ozone. Thanks for watching.